On train journey, a musician is invited by a gambler to play a dice game. Right? So this game uses two ordinary dice, which the musician is to throw. So I'm going to throw two dice on the musician. If my total score is 12, the musician is paid $6. Right? So 12 musician gets. So if the total score is 8, the musician gets paid $3. Right? However, if the both or either dice chose a 1, then the musician pays the gambler $2. Right, so if it's anything else, then actually they just both just throw it off, or both will get 0. So the variable here is to let x be the amount paid to the musician by the gambler. Alright, after the die, so you have to read this question because a lot of time people don't read and they just jump into the question without even understanding what the question needs and how to define the proper variable. So here we are looking at x first. And x is the amount that the gambler pay the musician. Alright. Show that the probability of x equals to 6 is 1 over 6. Alright. And determine the probability distribution of x. So one way, because we're actually looking at the distribution, alright, so we can actually draw a table of outcomes. Alright, so if we have, for example, throwing two dice, right, and then those in red are just the sum of the dice. Right, those in red are just the sum of the dice. So if you look at the probability of getting okay, if equals to 12, right, the total score is equals to 12, and then the musician will be paid. So there's only one 12 here. So this is the only probability. If you think about it, it's just like 1 over 6 times 1 over 6. And this is the only possible outcome in which the musician will be paid $6 by the gambler. Right, but if the total score is 8, right, so let's look at 8. Where we have 2, 3, 4, 5. Right, so you can see that over here, if this is 1 over 36, then you can see that the probability that I'm going to get $3 paid by the gambler will just be actually 5 times of 1 over 36, which is like 5 over 36. Alright, if both the or either die shows a 1, then the musician in turn he has to pay the gambler $2. So if we were to look at x, where x is the amount paid by the gambler to the musician, alright, so remember x is the amount paid by the gambler to the musician. Alright, so here x is equals to 3, and here x is equals to 8. Sorry, not 8, 6. Alright, and if we think about this, if we're going to have either or both dice showing a 1, then the probability of x is going to be like equals to like -1. Okay, because the gambler does not have to pay any money, in fact he gets money. Alright, so where will it be 1? So you think about it, the probability of getting a 1 is quite high. So there's actually quite a few possibilities. So you look, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you think about it, it's actually 11 out of 36. Alright, with this, alright, we can actually write out our probability distribution function table. Alright, our x is the amount that the gambler passes to the musician. Alright, it is possible that the gambler can be getting $2, so he pays an amount of -2. There's a possibility that he could be giving $3 to the musician. There's a possibility that he will be giving $6 to the musician, and there's also a possibility that they don't pay anything because it's neither outcomes. And to pay -2, either of the dice is going to show 1, so it's actually 11 out of 36 as we have found. Alright, and for when we get 3, it will be 5 out of 36 because it means a score of 8. A score of 12 will give me 1 out of 36. And if you look at all this, just take 1 minus the first 3, and your last outcome, which neither gets anything, will be 19 out of 36. Alright, and with that, we're actually done with the first part, which is we have determined the probability distribution of x. Okay, then we need to find the expected value of x and show that if the musician plays the game 100 times, and if the musician plays the game 100 times, the expected loss would be 2.78 to the nearest cent. Alright, okay, very quickly, let's go and find the expectation of x. So this is very easy. all I need to do is just to compile, all the x values. Alright, computing this, your answer will just turns out to be negative 136, or you can say it's a negative 0.0278. Alright, so the expectation of x actually is if you round it off to the nearest cent, alright, it will just be negative 0.03. Alright, if our musician were to play the game 100 times, the expected loss, right, we want to find to show that if the musician played the game 100 times, the expected loss would be 2.78. So what does it? It really means that if you're playing the games 100 times, right, it's like x1 plus x2 plus all the way up to x100. We're playing the game 100 times. And this is the same as, we're just taking 100 multiplied by the original expectation of x, which would just be negative 2.78. Alright, and then the expected loss, basically you see it's negative 2.78, so the expected loss would be negative $2.78, alright, which is shown. Okay, and now find also the probability that the musician is paid $6 at least once in 100 games. So here we define a new variable. Because we are talking about something else, right? So when you think about it, we're actually looking at like binomial, where this is like my n, and the probability here, the probability here is that the probability that I'm paid musician. So it's like probability that, let's say if I call it w, it's like w equals to, for example, at least once, right? So it's like w or equals to 1, right? So here let's think about how to define the event property. I'm going to play 100 games, so W, and the probability I'm going to find is that at least once I get paid $6. Let W be the probability, the number of games out of 100 for which he is paid $6. Alright, and then W, because you're talking about the number of games, the number of games are 100. So W actually takes on the binomial distribution of 100. And what's the probability here? The probability is the probability that x equals to 6. The probability that x equals to 6. He's paid $6. So what's the probability? Remember, we were looking at it just now. It's actually just equals to 136. It's actually equals to 136. Okay? And with that, what are we finding? We're finding the probability of y greater than or equals to 1, which is just the same as 1 minus the probability of y equals to 0. And answer turns out to be 0.940, right? Just using your GC. Okay? Next one, find the amount, $8, right? So that the $6 would have to be changed to in order to make the game fair. Alright, so we talk about making the game fair first. This means that the expectation either of x, what does it mean? You remember there was a question similar to tutorial, is that we want to make the expectation of x like 0. It means that the gambler doesn't win any money, the musician doesn't win any money. So the gambler doesn't have to pay any money to the musician. So in this case, right, the expectation of x is just 0, because both sides won't win, won't lose. And if I want the expectation of x to be 0, remember that we were somewhere here. We want to change this 6 to a, such that this one will become 0. So this really becomes a question of, this 6 has to be changed to a, alright? And if we were to work backwards now, if I want to change this 6 now to a, alright, I'm going to get something like, negative 2. Alright, this will mainly works out to be the linear equation in terms of a. Alright, and very quickly, a is just equals to 7.